Right, so this is another question on Bayes' theorem, and this time what we have are two urns, right? They're called A and B. So urn or a box, it's just some sort of a container, and both of these urns have many balls inside them, all of different colors, right? So they have many different balls with different colors. So let me just draw a little partition over here, because I will need this. I've just figured out this new way of drawing straight lines, so I'm using it whenever I can. So what we have here are um, so there are many colored balls inside. So there is brown, right? We have brown balls, and we have yellow balls, and red, green, orange, tan, which is I think some sort of skin color, skin-like color, and blue, right? So both of these boxes have balls of these colors, and we are told what percentage of the balls inside each of these two boxes are of these colors. So we are told that 30% of the balls in A are brown, and 20% are yellow, and 20% are red, 10% are green, 10% are orange, and 10% are tan. There are no blue balls, right? So A has this distribution of colors. B has 13% brown balls, 14% yellow, 13% red, 20% green, 16% orange, no tan balls, and 20% blue, right? So all these percentages add up to 100. So this is the distribution, right? And what happens now is that you're allowed to take out one ball from each of the boxes. So you can put your hand inside only once, and you take out one ball. And you do this, so you take one ball out of A and one ball out of B, and you find that you've drawn a yellow and a green ball, right? Now the question is that given that you've drawn a yellow and a green ball, what's the probability that the yellow ball came from A, right? So this is the probability we are supposed to find out, right? Now this question looks scary, right? I mean, there's so much data, but it's actually quite doable. If you're willing to be patient, it's actually quite doable. So let's start out by doing the obvious, right? So let's start out by writing an expression. This is a conditional probability, so let's just write down the Bayes theorem for this. So the probability of this probability expression would simply be probability of yg given ya into probability of ya divided by the probability of yg, right? So probability of yg is the probability of drawing a yellow and a green ball eventually, and and this is the probability of drawing a yellow and a green ball given that the yellow ball came from A, and this is simply the probability of drawing a yellow ball from A. Now if we look at this expression, there are three terms. There are two in the numerator and one in the denominator, and actually I only know this right now. I only know the probability of drawing a yellow ball from A, because 20% of the balls in A are yellow. So if you asked me what's the probability of drawing a yellow ball from A, this would be my answer. As for the other two terms, I actually have no idea, right? So right now I don't know what they are. And so these are the two terms we need to find out. So let's do this piece by piece, right? So let me just scroll down a bit. And the first probability I'd calculate is the probability of drawing a yellow and a green ball. So let's calculate the denominator first, right? So if you think about this, there are only two ways of getting a yellow and a green ball, right? You can get a yellow ball from A and a green ball from B, or you could get a green ball from A and a yellow ball from B. There are only two ways in which you can get a yellow and green combination, right? So you can, right? So which means that the probability of drawing a yellow and a green ball is simply the probability of drawing a yellow ball from A and a green ball from B, or drawing a green ball from A and a yellow ball from B. There are only two ways in which this can happen. And this can be, each of these terms could further be expanded to probability of drawing a yellow ball from A multiplied by the probability of drawing a green ball from B, or the probability of drawing a green ball from A into probability of drawing a yellow ball from B. So this is simple enough, right? Now each of the four terms over here, so we've got four terms over here, we know their value, and we'll just pick it off the table and we can calculate probability of yg. So let's do that now. So probability of drawing a yellow ball from A, how much is that? Well, from the table 20% of the balls in A are yellow, so that's 20%, so that's 20 by 100 multiplied by probability of drawing a green ball from B, which was 20% again, so that's 20 by 100 plus probability of drawing a green ball from A. So green, this is A, so this is 10%, so that's 10 by 100 multiplied by the probability of drawing a yellow ball from B. So yellow is here, this is B, so that's 14%, so that's 14 by 100, right? Simple enough. Now you can do this calculation, right? And the answer comes down to 27 by 500. So you can use a calculator to figure out, to do this calculation. You can do this with a pen and paper. However, the calculation is not that important, but this is what it comes down to. So the probability of drawing a yellow and a green ball is 27 by 500. So we've got one missing piece down. So we've got the denominator now. So we know this. So this is good. So all that we are left with now is this one term in the numerator, which is, let me just section out an area, which is probability of yg given ya. So the way to read this is, what's the probability of getting a yellow-green combination given that the yellow comes from A, right? So think about this. If you have to get a yellow and green combination, so you need two balls, and you already have a yellow ball from A, then the only way in which you can get a yellow and green combination is if you get a green ball from B. There's no other way of getting it. So the probability of getting a yellow-green combination when the yellow actually comes from A is simply the probability of drawing a green ball from B, because that would be the next thing you do. You've already put your hand inside A once and taken out a yellow ball. Now all that you need to do is put your hand inside B, and you should draw a green ball, right? If you want a yellow and green combination. So so the probability of getting a yellow-green combination given that the yellow comes from A is simply the probability of drawing a green ball from B, which we know. We can look at the table. So if I go back up, the probability of drawing a green ball from B is 20%. So this comes down to 20 by 100, right? So now we've got this last missing piece in this expression here. In fact, I think I should probably just write it down again. So what we are looking for is this is our original expression, and this was equal to probability of yg given ya into probability of ya divided by probability of yg, right? So this what we found out was this over here, so that's that, and this is this thing over here. So we have all the values that we need, right? So it's just a simple question of plugging them in. So we got 20 by 100 in the numerator multiplied by the probability of drawing a yellow from A, which was 20% again, right? So that's this value over here, right? So let me scroll down. So that's 20 by 100. Yeah, this whole thing divided by the 27 by 500 that we got earlier, right? Now you can solve this using a calculator, and this comes down to 20 by 27, which is actually equal to 74.1%. So what this means is that if you've got a yellow and a green ball, then the probability that the yellow ball came from A is 74.1%, which is actually surprisingly high, right? I mean, I did not expect this when I started solving the problem, but probably the reason lies over here somewhere. So if you notice the contents of box B, you kind of notice that green and blue, they really dominate the color scheme, right? They're 20%. That's the highest percentage. So if you put your hand inside B, then you're more likely to draw a green than any other color, right? And so if the green is more likely to have come from B, then and you eventually land up with a yellow-green combination, then just to compensate, the yellow is more likely to have come from A. So perhaps the intuition is that, right? So perhaps that's the reason why the probability of getting a yellow from A was so high, right? So this was the question. It looks scary, but it's actually not. So if you're patient and if you're just ready to take one step at a time, you'll find that you can solve almost any maths problem. So hope you enjoyed the solution, and thanks for watching.